I am very excited to introduce this next session. We're going to be moving over to North America now and talking about virtual protection relays. So we'll hear from some US utilities who are currently working to leverage this technology. But first, I would like to introduce Joe Jankowski, Intel's Director of Utilities and IoT, to say a few words. So Joe, thank you for joining us today, and over to you.
Hi, Aaron. Thank you very much. I think I was muted there for a minute from the host. Can you hear me now?
Yes,
Okay,
we can
great.
hear you, Joe. Yep.
Great. Okay. Aaron, thank you very much for the introduction. And before we move on to our utility panel, I'd like to spend just a few minutes on the journey to sort of get where we are today, as well as a short glimpse into the future. So 3 to 4 years ago, Intel's Prithpal Kajuria and Brian Roberts began to talk about substation automation with Southern California Edison, who seemed a natural fit because they developed a version of this nearly a decade ago. And together, we worked on the problem statement and use cases, drafted a high-level reference architecture towards building a new common substation platform, or what we call a CSP. We then brought in a couple of innovative rabbit technology partners. And I say rabbits, meaning not the large incumbent OEMs, to meet those hardware and software specifications, and built the prototype, which SCE tested in their lab, then in a few pilot substations. And that's how the journey began. And it is a journey, as you can see, that it took 3 to 4 years to get there. We then moved to the next phase, which was an ambitious virtual protection relay solution, or VPR. And for this, we wanted to increase the number of utilities. So together with SCE, we invited Salt River Project into the same process we followed with CSP, meaning defining the problem statement, the use cases, the reference architecture, developing a prototype with innovative partners, and testing it in a utility lab, in which SRP begun in this case. In addition, we also wanted to increase the number of participating utilities. So SRP and SCE helped bring in Entergy and AEP into this testing effort. And hence we have the VPR panel that you're going to listen to today. Now, just a very short glimpse into the future. Similar to the previously discussed coalition of European utilities and the ecosystem partners approved by those utilities, we're in the process now of creating a North American coalition focused on VPR, codenamed Viper. We know from our European experience that the collective strength of a number of courageous utilities, combined with innovative partners, that we can develop the next generation substation solutions. And in turn, those solutions, developed hand in hand with utilities, will spur the incumbent OEMs to build the substation hardware and software that utilities want. And with that, back to you, Aaron, from Zprime.
All right, thank you, Joe. So I would like to introduce our panel today. We've got a great panel of utility representatives. So we've got Kevin Sharp from Southern California Edison, Sean Boyer from Entergy, and James Wolf from American Electric Power. Thank you all for joining us today, virtually, of course. So we've heard a lot today about flattening the grid and how the utility industry is transitioning to a more digital grid as a platform model. And transitioning to virtual protection relays will be a part of that overall transition, and something that each of you are working on at your utility. So to start us off, I'd kind of like to just hear from each of you what you're really working on, what problems or use cases at your utility does VPR help to solve or improve upon? And James, I'll go ahead and start with you.
Sure, thank you, Aaron. The challenging part right now for us of the digital substation conversation to date is that we keep circling back around the topic of how to reduce the number of devices in a substation, not add more. So far, we've deployed a number of different available commercial products. The digital version of the substation we've seen is that it starts to look like a fiberized version of quote unquote, the way we've always done it. We've not yet been able to reduce the number of devices nor gain vendor independence as of yet. So once we start to separate that sampling function from the processing and decision-making engine part of a relay, the modern protection that we know today, we're really just collecting data to use however we see fit. So as long as that sampled data that can be reliably connected and communicated, a consolidated protection and diagnostic platform lets us gain the freedom to start innovating with our own real-time data. And looking at the VPR and any other consolidated platform like that lets us start realizing that vision.
Great, thank you. Sean, how about you?
Sorry, just trying to mute myself. Yeah, so at Entergy, we're relatively new to this process. We've only been involved in this conversation for probably 6 months or so, but we've already been learning a lot about the potential problems that we can overcome with this technology. And from our perspective, at least Entergy services southeastern Louisiana or southeastern United States. So we get hit by a lot of hurricanes and storms and have a lot of flooding and that kind of, natural disasters. So we're personally excited about the speed of recovery for these kind of storms and disasters that wipe out substations with this digitalization of relays. And as a result, for this relay virtualization, we can also heavily standardize our protection grid. So those are kind of the two areas that we've been looking into.
Great, thank you. And Kevin?
Yeah, so we have similar requirements, but this has been a journey for us, and this has come out of some demonstrations that we've done when attempting to standardize on the design of a substation, standardize on the protection, and standardize on the automation schemes. And in pursuing a common substation platform and deploying some of those projects to the field, we have a new set of requirements that the VPR attempts to resolve. And a few of them are, we're looking for a smaller footprint. The control houses in a substation are becoming enormous with all of the different independent boxes required to perform all the functions that we're looking to have. To simplify the design, because it's a lot of wiring and a lot of manual settings of all those devices, and reduce cost. So the cost of construction, building, deployment, testing, commissioning of all of that equipment, if it can be automated, that could reduce the time it takes, simplify the design, reduce the cost of a solution. And we look at other things like hardening and fast recovery, redundancy, multi-vendor compatibility, and then ease of testing. So that's another area where if we start to virtualize, we can start to leverage applications to help regression test changes and help test commissioning and deployment of projects. And then, last but not least is open up the possibilities for new protection applications to resolve some of the problems that the future grid will have that there are currently no solutions for.
Great, thank you. And what about the challenges? Anytime you're implementing or trying to leverage a new technology, you're going to face, I'm sure, many different challenges. So again, I just kind of like to hear from each of you some of the challenges you're facing. And James, I'll start with you again.
Sure. So to date, we've yet to put our hands on the VPR from Intel or really any similar consolidated substation Cortex device that we've mentioned in the white paper that we published on the topic. Our experiences to date so far are on vendor provided copper to fiber communication solutions, just changing over simply from that copper-based system into that fiber-based communication system where a lot of our protection is done virtually. One of the things we found that's pretty obvious is we expect workforce training to require a whole new approach, one that specifically does not teach in the context of the way we've always done our work. This will likely include building the comfort level of relay engineers and field technicians to be able to work with a virtualized platform that feels almost more like an IT device than a dedicated function platform that we see from traditional relays today. Our challenges have really been related to the traditional mindset of protection engineers, I would say, who expect an extreme level of reliability from products when deploying them for system protection, especially for the first time. So right now, I'd say a lot of our barriers are focused on mindset and looking at what can we do in the future, not what can we do today.
And Sean, same question for you, challenges that you're facing.
Yeah, I'd like to build off of what James was saying. That we're going through very similar issues. It's building trust in a new technology, and we're in a very similar boat. We've yet to have the play with this particular technology, but in our digital substation research lab, it's exactly that, trying to figure out how to bring people in and have people be okay with this virtual communication. So that's the biggest issue that we're facing.
And Kevin?
So I would say that we had similar issues with technology adaptation. Utilities are very conservative, but the biggest challenges that we've been facing on this journey from the beginning, first and foremost, is finding vendors that have solutions that meet the needs of the project. And so it's been years where we've been sort of evolving the specification into what it's becoming today, leading to virtualization of the environment. The second is that those specifications require enormous resources and support from our IT partners. And the operational technology world and the IT world typically were separated at the fence of the substation. There were some telecom into the substations, but it really didn't cross over. So IT/OT convergence was the next big challenge. And so for a year, we worked with consultants to help us lay out a roadmap for building that partnership and the technology to support our endeavors. And we joined IEEE's IT/OT convergence working group. We looked everywhere we could to figure out how to rapidly build a partnership as opposed to a customer relationship with that organization and our own utility. Finally, cybersecurity challenges is the last big hurdle. It's come to a point where cybersecurity is a moving target because bad actors are constantly innovating. And so what we've ended up doing over the last couple of years is writing a substation cybersecurity standard that we adopted from our grid standard. And the reason we had to do that is because the operating environment, the type of equipment, the type of testing and deployment that we do is very different than an enterprise architecture. And so this is being published at the end of this year and will be used as a living document and guide for how we secure substations and grid data center connections going forward.
Yeah, Kevin, kind of to follow up on something you mentioned, kind of the, interactions with IT. How can you kind of talk more about what this means for how IT and grid operations will begin to interact in the future, and sort of how you see that working out?
So we have been developing a project management process that brings IT in from the very beginning of any project. And so every project that we have, it could be a single device or it could be a complete system integration, where we do architectural reviews of our proposed solution. We do risk analysis, and we do penetration testing of the final design. And then after it's deployed, we have playbooks that cover potential responses to outages or intrusions, maintenance and support. And all of that is integrated into our maintenance and inspection manuals, our support, because we have construction support, and now we have sort of like a hotline that we can call from the operational side to get IT support 24/7. So it took a lot of resources and planning to get to that point, and now it's a matter of scaling it up. You're muted, Erin.
Sorry, I was muted there. On our prep call for this session, we had a discussion about, open source versus proprietary software, and kind of ended up, seemed like the consensus was that really having standard protocols was really the most important aspect. So James, this question will be for you, but why are those interoperability and those standards, why is that so important when it comes to VPR?
So in the context of proprietary versus open source or open platform, our stance right now from what we've learned is we are not necessarily putting a label on what the solution has to be. We want to arrive at something that may not presently exist as it stands today. We're not specifically looking for something that's grounded in being standard-based, open sourced, or even for that matter, proprietary. There may be middle grounds that exist that vendors or utilities haven't quite explored yet. So as long as the answer affords us the flexibility to choose the best-in-class products while remaining vendor agnostic, we'll have satisfied our vision to be able to innovate and keep producing customer value through technologies like this.
Great, thanks. Kevin or Sean, do you guys have thoughts on that, standards, interoperability?
Yeah, standards are important, and all I would say about it is it's important for the utilities to participate in the standard process, so that it's not just manufacturers and vendors, but utilities also sharing in the responsibility of building those standards.
So Sean, you are sort of a newer entrant to this group, this coalition. Can you talk about some of the benefits that you found? Are there benefits to joining a group like this, for that other utilities might find beneficial?
Yeah, of course. So far, the support has been overwhelming. It's been really, really great, and that's kind of something that newer entrants need to get off the ground and up to speed to match everybody. So that's definitely the like one of the leading factors of joining if you're interested in researching this technology. And in the past, we've done very similar things when researching 67050, which is the digital protection standard, and we have created coalitions for idea sharing, and it generates a better product in the long end. And like I said, shared experience too is very, very important for moving forward, so that you don't get caught in the same I guess, downfalls that other utilities have been stuck in.
Great. So another question for all of you. What about the role of data? What kind of data are you looking for? What are you measuring? What is that, and why? What is the why? What does it ultimately help with? Kevin, you want to start on that one?
So, data can play a part in basically all aspects of operations. So it could be used to analyze a normal state of operation and look for anomalies for impending failures. So that may be some predictive maintenance offerings. It could be used for optimization of power flow. It could be used for analysis post-event to be able to recover as many customers as possible in as little time as possible. And it could be used to sort of measure the current state as we have resources at the edge of the grid coming online, going offline, such as PV or wind, and help maintain the stability of the system.
James or Sean, do you have anything to follow up on there?
The role of data, you have to match it to the problem that you're trying to solve. Data is in many ways a generic term, and you have to look at not only what is it data governance, is it data management? It's not just, oh, let's collect a lot of data and let's do the buzzword of machine learning or data analytics. You have to find out what you're targeted at. For example, as Kevin alluded to, power flow cases, linear state estimation, operation decisions, you need one type of data in one type of time frame to do that. But if you want to do, say, transient analysis, power quality monitoring, you have to start looking very carefully at the sampling technologies that you're using to collect that data in the first place. So you can collect data, but you have to really define what type of data you need for what specific problem to leverage it properly. And once we can get that data outside of that box that does both the sampling and the decision making and free it up to transform it into other applications, is when we can start self-innovating and realize that value.
Yeah, and then how do you ensure the quality of the data when it comes to VPR? Or is that a challenge that you're still dealing with? As he's smiling, James.
We still have to learn a lot about how the data processes from the sampling device to that decision-making engine to see what it looks like.
We have one question from the audience that came in so far, and so I'd like to encourage other audience members to submit questions, but I'm going to ask this question that came from Bob, no last name. He says, I'd be interested in how the panel see FUSA, functional safety, and TSN, time-sensitive networking, playing into future solutions. Anyone want to take a crack at that one? All right. That's okay. If not, we can move on to another question. What would you say are some of the biggest lessons learned since you've started your journeys into VPR? And Sean, I'll start with you on this one.
Yeah, I mean, so like I said, like we're relatively new, so I'm not sure that. I mean, so far it's just been a lot of communicating with other utilities and learning what their lessons have been. But in our past experience with other digital communications, and I think this is going to be super important for VPR as well, is that testing is key. You need to figure out how to test your operations successfully in a lab environment and push whatever you learn into the field before you can even get off the ground. So I imagine that's going to become a very important staple.
Kevin?
I wanted to jump back to the question really fast on the time sensitive networking. That is a bit of an IT question. And so as we started to develop a network design to handle the type of latencies required to do protection over the network and have a computing platform that operates at near real time, what we've had to do is rely on our IT partners a lot. And so it requires a lot of conversations and education about the operations and relying on IT to design a network that achieves the requirements of the standard and basically negotiate a level of service that is guaranteed from IT. And the repercussions of that are obviously cost, because the more reliable the network becomes, the more available the network is, the more redundancy and equipment is needed in order to ensure that. So I wanted to jump back and try to answer part of that question.
Thank you. I appreciate that. James, do you have any thoughts on the other question?
Sure. In terms of lessons learned, I often introduce myself as a recovering protection engineer. It takes a little bit of effort to change your mindset when you're looking at products that don't yet exist. So the advice I'd give to some other utilities that are looking at this are keep focusing on the problems that you want to solve and know how those solutions are going to benefit your customers in the long run. You really have to stay open-minded to alternative solutions, looking under the rocks that you never thought to look under before. And you have to be ready to maybe accept the first iteration of a product that doesn't look and feel like what you've always been traditionally used to. We had a number of tough internal conversations. And when we start looking at technologies like a VPR device, the first instinct is, oh, we should see a box that has this relay emulated in it with all these functions. Well, it may have that buried in there, but it may not look and feel exactly like that box that you're used to. But you still have to look at those technical SMEs that have been around and understand what works and what doesn't. And you have to give them the freedom to experiment outside of the boundaries of a vendor's off-the-shelf platform that's available today. So you kind of have to ask them for that expertise of, hey, not what do we need, but what is it going to take to get there? And you have to define that vision. What is there? And you as a technical genius, if you will, what do we really need to cross that line and get where we're not yet? And it really can't be overstated what Sean led off with. You really have to help further collaborative coalitions with other utilities. The innovation breach required here to get what we truly want is going to require a collective voice to really make that shift in the industry.
Yeah, and so who are some of the other stakeholders or partners that should be involved in those conversations?
It depends if you're looking just internally or externally. Internally, you have one set of conversations. Externally, you have another. Because when you're talking to, say, a sales representative, you're having one type of conversation versus internally of, well, okay, do we really know what we want and what the barriers are that we're going to cross? AEP, for example, issued a rather large RFI this year just to cross-section the industry and see what information was out there. I mean, I can't share specifics from the results there, but there is interest out there, but it's not something that's going to be handed off in the next 2-3 weeks. It's not, we've got something ready. There's going to be iterative baby steps to building the vision that we all have and are sharing here today.
Great, thank you for that. So we've had a couple more audience questions come in. This question sort of touches back on that resiliency factor. So Laura asks, what about reconfiguration of the distribution system when the grid is disconnected and the system is working in island mode? Anyone have thoughts there?
Yeah, I mean, I have some thoughts. I mean, it's interesting, but realistically, what we're talking about is virtualizing something that already exists, and so while some aspects of evolution change, a lot of things have to remain. So, for example, today protection stands alone. And it depends on the design of your protection. You may have a few boxes interacting with each other to make decisions, but for the most part, most decisions are made sort of locally. And then you have backup protection, so that if your local protection fails, that you ensure that some other area will respond to that event. And I don't really see anything changing. So if I don't know if you mean islanded from a power perspective or islanded from a network connectivity perspective, but I would expect it to behave the same. And because you have a digitized environment, there's a lot more freedom to be innovative, to come up with ways to have backups to backups.
Great, thanks. I'm kind of, I guess, switching gears a little bit to focus more on the customer. What kind of benefits does this transition to VPR? How does that, enable a utility to, in the end, deliver better service to their customers? Sean, you're nodding. I'll ask you to answer that one first.
Yeah, I mean that's what I touched on. That's kind of why we're even looking into this is a lower downtime of work in a substation. So if like I said, if we have a storm or something fails, you should be able to get the substation back up and running a lot faster, just using this technology. And that would in turn help out the customer get power faster.
Kevin?
Yeah, so there's, I mean, we envision a lot of benefits. One is hopefully there's some cost reductions. I see up front the initial investment, the cost is going to shift to other areas. I mentioned the need for network architecture and cybersecurity, and those are very expensive things. And so all the savings you're getting up front with, reduced copper costs for wiring, reduced wiring time, all of those will shift to other areas. But as you start to scale, you'll start, there's economies of scale, so you'll start to envision realize some savings in that process, and it'll probably be small. As you maintain the system and you have options of automating testing, you start to have less errors, more errors caught up front. You start to have less drive time to respond to an event, so that you can remotely respond to an event. So you improve safety of workers, you speed up recovery time, you reduce the cost of operations and maintenance, and then customer choice. So when you get all the way to the edge of the grid and the customers have the freedom to make decisions based on their needs, and they are realizing cost savings from that, and we have a grid that can enable that and adapt to whatever it is that they choose, I think that's when you'll see the most satisfaction from the flexibility and opportunity to save.
Great, thank you for that. All right, another couple of audience questions have come in. What is the utility's readiness to deploy digital process across all substations to enable VPR technology? I guess how fast would you intend to deploy this technology?
You want to
Is
stab at
that, is
first?
that one answer, or is it vary across type of utility, the size of utility? I'm sure there are various factors, but if you had,
Sorry, Aaron, specifically the process bus. I think that that's an
Yeah.
actual utility term that these guys will find, very important.
oh, I skipped that word, sorry.
Yeah, I could take a quick
Digital
stab at
process.
it. So I would say the process bus piece is ready, right? There are utilities around the world using process bus today. Not so prevalent in North America, but it's becoming more prevalent as options become available to us. The interoperability is still a bit of an issue, and the cost is really high. And so we're looking for the industry to reduce the cost of merging units, for example, because right now merging units are probably just an expensive relay that has some, process bus, this digitization of the analog signals back to your control building, along with all the other features that you're paying for that we don't really need anymore. And so as the cost of those units comes down, it's more of a practical solution. I think moving to VPR technology, that's a bit further out. So you'll start seeing utilities in North America deploying process bus designs maybe today or starting in the next year or two. We certainly have projects where we have fully digitized substations ready for demonstration. So those are being planned for a lab demonstration, and then will be eventually deployed to a field demonstration. Then the next would be sort of a wider spread pilot to look at training and tools necessary to maintain that fleet of digitized substations. And the VPR would probably be several years after that, because we need some confidence in this deterministic environment that we need, that we're expecting from computers, that we know we don't get today. You're writing a document in Word, and all of a sudden everything locks up because some process kicked off in the background and is eating up all of your resources. That's what we're attempting to manage today. And once we get our arms around that and are able to demonstrate that it works, you'll start to see a lot of enthusiasm and momentum.
Great, thank you. One other question: is there any movement to into the wireless private network space to support the digital substation? And then they have a comment: CBRS would be a possible solution and could involve edge compute and supporting analytics.
I'm going to go again.
Any insight? Yeah, if you've got insight on that, Kevin, go ahead.
Okay, I think it's maybe a bit unnecessary inside the substation. Wireless technology introduces more points of failure, is a little bit more difficult to manage, but it's certainly going to enable edge devices on your distribution system that will feed back into your substation. And absolutely, if you can bring that computing from your, you have your grid data center, and now all of a sudden you have this huge pipe of data to your substation, and you can collect more data and the right type of data in real time to make decisions. And now you're looking at private LTE or something going out to the edge. That can be leveraged for grid edge technologies such as DERs or sensors along the distribution networks, and switches, controlling switches to rearrange networks for flexibility. So the private LTE definitely has a role in the distribution space.
Great. All right, I think we've got time for one more audience question that just came in. What have been the biggest gains that you've seen after digitalizing your substations?
I'm going to try and take a stab at that, Aaron, and respond to some of the earlier questions about cost and customer benefits as well. I think what my peers here are highlighting very well is the possibilities here really are endless. You can gain any kind of advantage you want if you're willing to put in the work and build the system that you want. Once you have a digitized substation, and that's a pretty broad subjective term depending on how you look at what really is a digitized substation. The value that you can translate into customers and turn into any kind of gain is based upon who you give the freedom to innovate. If you have access to that data and you've broken apart what that data really means when you get it, if you need a fault analytics locating application, you can write it, you can put it in the platform. If you need something that is going to analyze a ComTrade record and tell you this is a lightning fault, not a tree fault, great, here you go. Start gathering the data and put it into where it needs to be. So the gains that we've seen so far with digitizing the substations that we have is starting to minimize copper wiring and getting those construction and maintenance benefits that are there. But also, you can't always put a price tag on knowledge. You have to have your hands on a product sometimes to figure out this is what the lessons learned are that we didn't know were here before. So once you've had a little bit of experience, trained a couple SMEs, started getting your field folks comfortable with it, that's when you can really start asking, okay, well, if we got this far, where else can we take this when we get the next evolution? I have one diagram that I usually put in front of folks that I love using. It shows back in the 1980s, early 1990s, when electromechanical relays started being collapsed into what we now know as the modern IED. You would take 3 or 4 panels worth of protection and collapse it into one with 2 boxes that were fully redundant of each other. That innovation in itself was landmark. And now we're looking at the cusp of the next evolution where we take those boxes and then we turn them what may be a 72-foot long control building into what may be 18 feet, maybe cabinets in a yard. It may be something that just doesn't look like a substation anymore.
Great. I think that was a great summary, a good way to sort of wrap things up here today. So thank you all to each of our panelists for joining us. I wanted to send it back over to Joe for a minute. He had one more thing that he wanted to say before we move on to our next panel. So thank you, Sean, Kevin, and James for joining us today. Thanks everyone for their audience questions. We really appreciate it. And Joe, sending it back over to you.